The internet feels invisible, weightless. Every message arrives instantly. Every video begins within seconds. Every AI response appears almost effortlessly. It is easy to imagine the digital world existing somewhere beyond the physical world, but it doesn't. The internet has an address. It lives inside buildings. Buildings filled with millions of processors, petabytes of storage, thousands of kilometers of fiber optic cables, and enough electrical infrastructure to power entire communities. Every search, every online purchase, every cloud application, every AI conversation travels through places like these. They are called hyperscale data centers, and they have quietly become one of the most important infrastructures of modern civilization. At first glance, a data center appears to be nothing more than rows of computers, but appearances can be deceiving. Each rack represents thousands of processors working together. Each cable carries information moving at the speed of light. Each storage system preserves part of humanity's digital memory. Every second, billions of requests arrive. Videos are streamed. Financial transactions are verified. Medical records are retrieved. Artificial intelligence models perform inference. Cloud applications synchronize across continents. To users, everything feels effortless. Inside the building, an extraordinary level of coordination never stops. Because this is not simply a room filled with servers. It is a digital warehouse, processing the daily activity of modern civilization. Information may travel digitally. Energy does not. Every search, every video, every cloud application, every AI response consumes electricity. Multiply that by billions of users across every hour of every day, and the result becomes astonishing. Modern data centers require vast amounts of reliable power, not because they are inefficient, but because civilization itself has become increasingly digital. As artificial intelligence grows, so does demand for computing. As computing grows, energy becomes one of the world's most strategic resources. The digital economy is often described as virtual. Its energy requirements are anything but. Behind every intelligence service, power is quietly doing the real work. Every calculation creates heat. A single processor produces only a small amount, but millions of processors, working continuously, generate enormous thermal energy. Without cooling, performance drops, hardware degrades, systems eventually fail. That is why cooling has become one of the defining engineering challenges of modern data centers. Massive airflow systems, liquid cooling technologies, intelligent environmental monitoring. Every solution exists for one purpose: keeping the digital world running. As processors become more powerful, cooling becomes just as important as computing itself, because intelligence can only exist if heat remains under control. The word cloud sounds almost magical, as if our data simply floats somewhere beyond reach. But the cloud is not a place in the sky. It is a network of physical data centers distributed across the world. Every document you save, every photo you upload, every movie you stream, every AI model you interact with, lives inside real buildings, protected by layers of physical security, powered by enormous electrical systems, connected by thousands of kilometers of fiber optic cables. The cloud did not eliminate infrastructure, it centralized it, transforming computing from something individuals owned into something civilization shares. If the internet is global, why does the location of a data center matter? Because information still travels through the physical world. Every additional kilometer adds time. Every network connection introduces delay. For applications like artificial intelligence, financial trading, cloud gaming, and real-time communication, milliseconds matter. That is why the world's largest data centers are carefully positioned near major population centers, near high-capacity fiber networks, near reliable energy infrastructure, sometimes even near abundant water for advanced cooling systems. The digital economy may feel borderless, but its performance still depends on geography.
Factories once transformed raw materials into physical products: steel, automobiles, machinery. Today's digital economy introduced something entirely different: factories that produce computing itself. Every second, they generate processing power, store information, train artificial intelligence, deliver cloud services, support scientific research, and keep businesses operating across every continent. Nothing physical leaves the building, yet immense value is created inside it. Perhaps that is the defining characteristic of modern civilization. The most valuable products are increasingly invisible, not manufactured as objects, but delivered as capability. In the 21st century, computing has become an industrial resource, and data centers are the factories that produce it.
Unlike traditional industries, the digital economy never closes. When one city falls asleep, another begins its day. Financial markets continue processing transactions. Hospitals continue accessing patient records. Factories continue communicating with automated systems. Artificial intelligence continues answering questions. Millions of businesses continue serving customers across continents. Behind this continuous activity, data centers operate without interruption. Engineers monitor infrastructure around the clock. Backup systems stand ready before failures occur. Power flows continuously. Cooling systems never stop. Because in a connected civilization, availability is no longer a convenience. It has become an expectation. The digital world never sleeps, because modern civilization never does.
Most people never think about data centers, yet almost everyone depends on them. Every digital payment, every navigation request, every online classroom, every video conference, every streaming platform, every intelligent assistant, every cloud application. Behind each experience, a data center quietly performs its task, not seeking attention, only reliability. These buildings have become something greater than technology infrastructure. They have become part of society's operating system, an invisible backbone supporting communication, commerce, science, healthcare, education, and countless aspects of everyday life. The digital world may appear intangible. Its foundation is anything but. Every era has been defined by the infrastructure it built. Ports connected empires, railroads connected nations, power grids electrified cities. Today, hyperscale data centers connect the digital world. They do not manufacture steel. They do not assemble automobiles. They manufacture something equally valuable: computing, the invisible resource powering modern civilization. As artificial intelligence grows, as cloud computing expands, and as billions more devices come online, these facilities will become even more essential. Because every digital innovation, no matter how intelligent, no matter how advanced, must ultimately pass through buildings like these. The future is not powered by software alone. It is powered by the infrastructure that allows software to exist. In the next episode, we follow the information leaving these buildings and entering the fastest communication network humanity has ever built, the global fiber optic network, the invisible highways of the digital age. NEXNET, the architecture of modern civilization.